Last episode, we shrank attention's notebook all the way down the Kavikash ladder, but attention was never where most of the parameters live. 2/3 of a model sits in the little neural net after attention, the FFN. So here is the question: what if instead of one neural net per block, the model had 256 and opened only a handful per word? Picture a dense model as one brilliant generalist who personally answers every question. Thorough, but every word you ask runs that entire brain. Mixture of experts is different. It is a library of specialists with a smart front desk. A word comes in, the front desk glances at it and sends it to just the 2 or 8 specialists most likely to help. Enormous total knowledge, tiny cost per word. That gives us two numbers that finally come apart: total parameters and active parameters. Mixtral has 8 experts and picks the top 2 per word, about 47 billion total, but only 13 billion actually fire. Careful, it is not 8 times 7 because the attention layers are shared across all experts. The capacity is huge, the bill per word is small. DeepSeek pushed this to the extreme. Instead of 8 big experts, it uses 256 small ones, plus one expert that is always on for the common stuff, and it routes the top 8 per word, 671 billion total parameters, 37 billion active, and it solved the classic MoE headache, lopsided routing where everyone crowds a few experts, with a clever load balancer that needs no extra loss term dragging quality down. But MoE is not a free lunch, and this matters for serving. You save compute, few experts fire. You do not save memory. Every expert still has to sit in GPU memory ready. And the router has to shuffle tokens to the right experts across GPUs, which is real communication traffic. MoE trades cheap flops for expensive memory and plumbing. Let me put dense and sparse side by side. On the left, the dense block. A token enters, the one FFN, the whole thing lights up, out it comes. Now the sparse block. The token hits a router first, a tiny gate that scores all the experts. Watch the scores, it picks the top 2 and lights only those. The rest stay dark. Same token, a fraction of the compute. Here is Mixtral concretely. 8 experts, top 2. The active parameter counter ticks up to about 13 billion, while the total parameter counter reads 47. Two numbers far apart. That gap is the whole point of MoE. And DeepSeek, 256 rooted experts in a fan, one shared expert glowing permanently on the side, top 8 lit per token. The counters now read 37 billion, active against 671 billion total. The bias-adjusted router keeps the lit experts spread out, not bunched. One last thing to close the family story, because people confuse it constantly. DeepSeek R1, the reasoning model, is not a new architecture. It is this same MoE base taught to reason after training with reinforcement learning, then distilled into ordinary Llama and Quen models, small enough to run on one card. Reasoning is a recipe, not a new chassis. So now you have seen the whole parts catalog, norms, positions, attention, the KV ladder, and experts. Next, we stop talking and read the spec sheet, open real config files, and name any model's family on site. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.